let's see, 5.4 should have been where we left off. We didn't talk about 5.4, did we?
We did a little bit.
Just a little bit? Okay, so the big thing with 5.4 is they're just asking, did we do the first difference where we had to, we did do the first difference. Okay, perfect. And so then you learned about the exponential growth and decay can look a certain way other than, it could be 1 plus r, and in the homework they gave you what the a, which is the initial value, and they gave you what the rate was. And all you had to do was either plug it in the calculator, so we did that as well. So let's see where we are. All righty.
The practice.
Yeah, we did finish it.
We did 5.4? Okay, so in the homework you had where it asked you to, for this particular slide in the homework where it asked you to actually go in and put different things in Zuru. So you had to paste your data in the linear, you had to paste the data in the quadratic, you had to paste the data in the power, you had to paste the data in exponential and see which one was the best equation. So that was part of the homework for 5.4. So were there any questions about 5.4 before I finish this up with 5.5? Any specific questions on the homework?
I think I might have had a question. You go to
Okay, take a quick look. Take a quick look for me. Oh, and let me give you guys the sign-in sheet. Wow. While you're looking. Now, since we've already pretty much finished 5.4, that kind of gives me a different look on things that I will ask you at the end of class what your preference will be. Today is the 20th. Okay, any questions yet? You still waiting for it to come up? Okay, that's fine. You can ask me towards the end if you find it, if it comes up before then. Let me go ahead and talk about 5.5. So here we are. This is the last 3 slides for chapter 5, and it's about money. I like talking about money. We just want to make sure we get more of it, right? So again, it's about money and investing money, and you can kind of get an idea of what that should look like, especially if you've had anything where you put money in a certain place. So here is the first one we're going to look at. It wants us to figure out if you can determine what the future amount your money will grow to if you put it in some type of investment. Can you tell how much money you will have in 5 years, and 10 years, and 15 years based upon a formula that you'll be given? So in any financial market, they use something like this. They're not having to do it by hand because it's already built into the software that we usually use for financial stuff like this. So you're not going to see anybody at their desk if they're a financial analyst and they plug in numbers into this formula. No, they already have a software tool that has this already in it. They can just put a rate in, put a time in, and it'll calculate it for them. So here's what we're going to do. It says we're going to find the amount to which an investment grows over a period of time, which is why we call it future value. And it's going to tell you that you will have something called interest, and interest will be compounded a certain number of times. For this very first one, the interest is compounded annually. Think of compounding as something that gets multiplied over and over and over and over and over and over again. So in this particular second bullet, it says the interest is compounded annually. Okay? In the second bullet, the interest is compounded over a certain period of time. So we're going to talk about the periods. So they're periodically compounding. And in the third bullet, it just keeps compounding all day, every day, 24/7. It never stops compounding. So again, we're going to look at each one of those different types. So in this particular case, can you see that they're going to give you a value for P? What does P stand for? It's your principal amount that you invested. So let's say you got $1,000. That's your principal amount. That's what P stands for. The rate, Might be 3%, 5%, 0.1%, whatever the bank tells you or the investment company tells you. T represents time. It's usually in years. Sometimes it'll say months and then you gotta convert it to years, but usually that's what the T stands for. All right, so with that said, let's look at bullet number 2. What's the difference between the equation in bullet 1 and the equation in bullet, the equation in bullet 2 and the equation in bullet 3? What's the difference in the equations?
Divided and multiplied.
Okay, so I've got something different here. What's different in this equation? What's different?
How the interest is compounded.
How the interest is compounded. What letter of the, or what variable am I letting represent the compounding?
The E.
The I.
In this one? In this one?
The I.
The K.
The K. So notice there's an R here, there's a T here, we got an R and a T here, and we got a 1, we got a P. What's different is the K. The K represents the compounding. So here's how we determine compounding. So here's what you'll need to know. So this is K equals the compounding rate. I'll call it a rate, but it's not a percentage, it's just how often it compounds. I'll just say how often compounding. Okay, so K could equal annually. Well, how many times a year is annually? Once. Okay, so that's 1. So that means K would be equal to 1. Alrighty, what would it be for the next one? What's another type of something that you usually say it? Quarterly. Okay, so I could use quarterly. What else? I'm gonna put quarterly here because there's something in between quarterly. What's in between? Semi-annually. How many times a year is semi-annually? Twice a year. So that means K is 2. What about quarterly? How many times? 4. What else? K could equal daily. I'm gonna put daily down here. There's some other stuff in between daily. What's up between monthly? How many times a year is monthly? Alrighty. What else?
Weekly.
We could do weekly. Some people have something called bi-weekly.
Oh, yeah.
You could do bi-weekly.
So it could be 26.
Mm-hmm.
52.
Weekly is how many?
52.
52 weeks in a year, and then you said daily is how many?
365.
365. This is all the values K could represent. So in the homework, it's gonna say you have $1,000 at 3% invested or compounded weekly for 6 years.
What does T stand for?
Time in years.
Oh, in years.
Time in years. So
That's the K is the compounding.
K is compounded, T equals time in years.
So how long you hold the investment?
Correct. If the homework tells you it's 24 months, do you have to convert it to years? Yes, you do, because that T is in years. Okay, so just make sure you know that if it says months, you got to convert it to years.
Would you put a decimal in there?
For
time in years, like say it says 42 months.
it's usually going to give you something like 36 months, 24 months, or a half a year. It usually won't do it at an odd, it's either going to be a full year or usually a half a year.
Okay.
Okay, questions? So now you just plug in P, R, T, or K. Now let's look at the last bullet. The compounding for the last bullet is continuously. When do I use this one? In the homework, it's gonna say it compounds continuously, it never stops. So thus you always have to use the PERT formula. So that's always gonna be whatever your initial amount of money you're gonna invest, times E, right? So whatever the rate is over however many years they say. So for this particular topic, you're just plugging in numbers and calculating the answer. Question?
What kind of financial investment is compounded continuously?
I can't tell you specifically because I've never had one do that. But that's part of this lesson. I've never had one do that. I would like to find the one that does that, but I don't think anybody's doing that like now. I don't know where that, I have no idea. But it was part of this lesson, so I had to tell it to you. But yes, if you find it, let me know. I'd like that one.
We'll invest together.
So, and here we go with this last slide. Now, this is if you have some money that you want to invest, you want to know what its value is in the future. Here's the next slide. It says, what if I need a lump sum of money? How much do I have to have right now? If I need to come up with or save a lump sum of money, how much do I have to have now? This is called the lump sum formula. Now, I need you to change it because those letters that you see there need to be changed to the other letters that you had on the previous slide. So I'm going to change this right now on the fly so you don't have to worry about it. That should still be R divided by, whoops.
What did you say it was called?
This is called the lump sum formula. And let me see if it's going to let me put this fraction in here like I want it to be. All right, hold on. Let me go back to the other slide and copy this for a second. Copy. And now let me go to the next slide. And paste that right there. All righty, and then this is being raised to the KT. All right, did you see how I changed that? I changed this formula, so go back and fix whatever it had there. Let me reduce the size of that font. Well, I didn't want the whole thing to reduce. All right, we'll leave it. I'll play with that later. All right, so you got what we did here? What did I change? I had an I and an N here. It really is supposed to be what I have here now. So on your PowerPoint, change it. All right, what's the difference between this formula and the previous formula we had on the screen for the last slide?
Is it the inverse?
It looks like it's the inverse. You take all of the stuff that we had and put it on the bottom. Okay, so with that said, here's how this works. I want to buy a car in 2 years. The car that I want is going to be $50,000. Okay, so I want to buy a car. How much money is my lump sum going to be that I need?
50,000.
This is my lump sum. This is what this says. Lump sum I need is $50,000. All right, so if I want that much money, I found out that the bank says that I can invest some money at 5% for compounding monthly. I'm just writing this in here so you can see. So I've got 12 times, and this I could do this for 2 years. Or at least I'm saying I want to get this done in 2 years. So you've got to put all this in the calculator. The answer, and I'm sorry, this should be, lump sum should be here, guys. This is the lump sum amount. I didn't mean to put that S there. So this is P. This says, what does P represent from the previous problem again? The principal amount. That's what you have to have or already have. In the previous lesson, in the previous slide, it was the money that you actually currently right now have. Right now, this is the principal amount that you need to have right now in order for you to have $50,000 in 2 years. You see what I'm saying? P is how much money do I need to have in my bank, in my account right now so that I can have $50,000 in 2 years.
Oh, that's cool.
So it's going to tell you what you need right now if you want to do that. So if we put this in the calculator, it's going to give us an idea of what we need to have right now. So your lump sum is just how much money you need in 2 years. So if you put all that in the calculator, how much did it say I need?
For right now,
How much money do I need right now?
I came up with 45,251.27.
Well, that didn't help me out a whole lot, did it? Yeah, but that's the point, though. If you need $50,000, you probably may need, unless you hit the lottery or sell a couple $1 million houses, you know, you're gonna need a little bit more time to get your $50,000 together. You understand? This is not 45 exactly. I just wrote 45,000. You're gonna get an exact number. What was the exact number, Robert?
45,251.27.
$251.27. So this one I need to have in my account right now if I wanna have $50,000 in 2 years, given the interest rate.
Interest rate, we need the
5%. You had to write it as 0.05. Anytime you see the interest rate, you write it as a decimal. Okay? So this would work for anything. If you know the interest rate on the money that you're gonna invest, that says I gotta put $45,000 in the bank or in one investment and let it sit there for 2 years at 5% and it's compounding every month, this is how much money I'll have in 2 years. I'll have the 50,000. But this formula just tells me how much money do I need right now to initially invest. We got it? Okay. That's the end of 5.5. So the only things that you needed from 5.5 were these formulas for determining your future value of the money or how much money you need to have right now. That's it? Okay, so I have a question for you. At this point, I can take a look at chapter 6, which might be 5 slides, and that still would mean you'll still get the study guide this weekend. I could change your test and make your test to Wednesday, and then we'd have 2 days to study for the final exam. We'd have Friday and Monday, or we can keep the final exam on Friday and still just have 1 day to study for the final exam on Monday. Okay? It has to be a consensus by the whole class, so it has to be, everybody has to tell me what they think, and it has
So
to
we
be.
only got one test left, we don't gotta take one for 5, we just gotta take a final exam?
No, you have a test 4 and a final. So the final exam is May 7th. So this is our test 4, because remember, you take 4 tests, but I drop the lowest grade for whichever one is your lowest test grade. And you might say, I got all 95s on all my last 3 tests. I don't want to take the 4th test. That's up to you. So that's what I'm saying. So we have the 4th test left to take, which can either be Wednesday or Monday. If we take, Wednesday or Friday. If we take it on Wednesday, you have Friday and Monday to do, we still practice for the final exam, or we'll just have Monday to practice for the final exam.
Let's do the 2 days of practice for the final exam.
So what's the consensus? Y'all want to take the test on Wednesday? Raise your hand if you want to take the test on Wednesday. Okay, so that's everybody but maybe one. No. Wednesday.
It's the longest period of time.
Okay, so test on Wednesday. All righty. So I will send out an email letting everybody know test is on Wednesday. I will send the study guide out this weekend so you can practice the study guide. So let's go ahead and talk about chapter 6. It's only going to take me a few minutes. I know you don't have the PowerPoint for it, so just hold on a second because I will send it to you. Let me pull it up. Where's mine? Where is it? All right, chapter 6, here it is. I will send it to you guys towards the end of class so you'll see it open. All righty. Chapter 6 is talking about higher degree polynomials. And when they say higher degree, it just means anything with the highest exponent above 2. So these 2 that we're just going to focus on in this section is just exponents of 3 and 4. The higher degree polynomials we're going to talk about in this section, the highest exponent is going to be a 3 or 4. We call them cubic and quartic. So that's what that says, okay? It has degree higher than 2, which is going to be 3 and 4. Now, that bullet number 2 that you see on the screen says it has at most n intercepts. N is the degree. So if it looks like this, let me just give you an example. All right, here's an example. Y equals x to the 3rd plus 2x plus 1. Is it a higher degree polynomial? Is the exponent higher than 2?
Yes.
Yes, okay? So again, it says n is the degree, so that's a degree 3. So the highest exponent is called the degree. So The highest exponent of 3 is a degree 3. The highest exponent of 4 is a degree 4. If the highest exponent is 5, it's a degree 5. So this one's a degree 3. So if it's a degree 3, it can have how many x-intercepts? 3. The most it can have is 3. That just means it could touch the x-axis 3 times. Does it have to touch the x-axis 3 times? Look what this word says. At most, it could have up to 3, but it doesn't have to have 3. It could have 1, it could have 2. We'll find out in a second how many they usually have. So here is the first, or some characteristics of these. They'll have extreme points. When we say extreme points, we just mean they'll have maximums and minimums. So here's what that equation that you see on the screen over there. Y equals x to the third plus 2x plus 1 could look like this. It could look like that. What are the extreme points? The tops and the bottoms. Look for the mountain tops and the valleys. How many do you see? 2. Those are your extreme points. So if they say, what's the minimum point? You're going to tell me this one. If they say, what's the maximum point? You're going to tell me this one. You're just looking for the top of the roller coaster, bottom of the roller coaster. That's it. These are called minimums and maximums. Now, it has also a name for absolute maximum and absolute minimums. Well, what if I have a curve that looks like this? Hold on, we need to write another one. This is x to the 4th plus x to the 3 plus 2x plus 1. Here's what this curve might look like. Well, how many mountaintops and valleys do you see? And I'll just take this off so you see. How many mountaintops? 2. How many valleys?
1.
All right, so this is a minimum. This is a maximum. And what's this one? That's the absolute maximum. The absolute maximum is the highest mountaintop you see. The absolute maximum is the highest one that you see. The other ones are just local. All of them are local, but the absolute is the one that's the highest. If I had 2 minimums, the lowest one would be the absolute minimum. If there's only one max and one minimum, they're just both locals. There's no absolute if there's not 2 of them. Okay, so with that said, here is a typical equation that's a 3rd degree. So we create them. Here's what it's going to look like. It'll say f of x or y. And again, it's going to say x to the 3rd plus 2x. It could have a 2 plus 2x squared plus 4x minus 15. This is an example of what you see on the screen. The basic, when they say the basic function, the simplest one that you could have is this one. That's the simplest cubic function you can have. So simplest cubic function is y equals x to the 3rd power. Okay? Now, this one specifically says how many turning points could it have? Or nothing in between, nothing else. So either it's got 2 or none. Alrighty, last 2 bullets. This one says curves up on the right if the leading coefficient is positive. So is the leading coefficient here? What's the leading coefficient when there's no number here? Look at this one right here, 1. So if it's positive, it says it's going to open up on the right. So is this the right side of the curve? It opens to the ceiling on the right side of the curve. So up on the right. This is considered the right, down on the left. When does this happen again? when the leading coefficient is positive. So this could be y equals a positive x to the 3 power. Then this last bullet, what does it say? What happens if it's like that? What if I have a negative x to the 3rd power? Then guess what? It's going to open like this. So it's going to be up on the what?
Left.
Up on the left and down on the right. So this refers to this one, and this refers to that one. Okay, here is the next one. Any questions about the cubic functions? That's all you need to know about cubic functions. How many turning points? Do they open up and down? On what side? Maxes and mins. Questions? Alrighty, so we're doing the basic same thing for the 4th degree polynomial. So again, we just did the 3rd degree polynomial. Let's do the 4th degree one. I'm gonna write that one over here. Alrighty, so for 4th degree polynomial, here is the basic or the simplest one is this one. Here's the simplest quartic. Notice it's called quartic function. Okay, here's one that has a whole lot more. So I've got 3x to the 4 plus 5x to the 3 minus 2x to the 2 plus 6x minus 4. I just made all that up. Okay? Alrighty, so we see the simplest equation that you could have. Here's one that's a little bit more terms in it. Now, here's the question. How many turning points could it have?
1 or 3.
That's it. Can't have 2, can't have 5. It's got 1 or 3. Usually, it looks like this. Usually, it looks like a W. Doesn't have to be a perfect W. Could it look like this? Yeah, it doesn't have to be a perfect W. It could look like that. So it just depends on when you put it in decimals what the actual shape looks like. Okay? It could have how many turning points did it say? 1 or
3.
Well, how many do you see here? 1, 2, 3. When they say turning points, those are just your max and your mins, right? They're the same as your max and min. So turning points and max and mins are the same thing. So here, this is a max, which is still considered a turning point. Here's a min. Here's a min. Okay, these are also called turning points. Turning points. Alrighty? So, the 5th bullet says both ends open up. It starts off with a positive. So, what number starts this one off? Positive 3. So it's gonna, both of them will open up. What happens if I change this and say if f of x is equal to a negative x to the 4 plus 3x squared plus 2. Do I have to have all the rest of the terms in here? Look at this one I just wrote on the board. Do I have to have x to the 3rd, x to the 2nd, x to the x, all? Do I have to have all of them? No, as long as it starts with x to the 4. Alrighty, so because this negative is in the front, what's my shape gonna look like? It's gonna look like an M. Does it have to be a perfect M? Nope. So, negative in the front. So if it's a negative as a leading coefficient, it's going to open, both ends open down. Both ends should open down. Now, again, does it have to have 3 turning points? No, it could just have one. Meaning, it could look like this, where you can barely see there's a turning point somewhere here. It could look like that. You can't even tell there's a turning point right there. That means it's just one turning point. It's gonna look like a parabola. That's what I'm saying. It could look like a parabola because you can't tell there's a point there.
Is that only if it's negative?
No,
No.
it could do the same thing. It could do the same thing with the positive one. It could look like a parabola. It'll look like that. And you can't tell there's a curve there.
Okay.
So that's why it says it could be 1 turning point or 3 turning points. So it could look like a parabola, even though it's not. It could look like a parabola. Questions? The last slide, last couple of slides in here, all it wants you to remember is that you can put this in, you can put data in. Guess where you're going to put some data? You could paste the points in Desmos, but where are you going to get your equation from? Zero. So let's just show you how to do this in Zero. So in the homework, they're going to give you some data, and they're going to say, can you find the cubic equation or the quartic equation? So let's go find out where I need to go to get the cubic or the quartic equation. So I'm going to go to Zuru again. Here's my Zuru website, regression tools. Now, I need quartic and cubic. Which do I pick? PR, because that's the only one that lets me change the degree at the bottom of the page. Remember, for quadratic, you had to pick PR. Remember, and I said, look at the bottom and make sure that's a 2 for quadratic. But for quintic, excuse me, not quintic, for cubic and quartic, what do you change this to? 3 and 4. So when you want cubic, change it to a 3. When you want quartic, change it to a 4. Paste your data and it creates the equation for you. That's it. That is it. So if we take a look at the homework, just to see what you should expect to see there. All right, let me log back in to the homework. So chapter 6 wasn't that bad, was it?
That's it.
That's it. That's all of chapter 6. That's why I said chapter 6 is actually fairly easy. So if we go to the homework, look at and see if you see anything. Which one did I? Let me look at 5. I want to just see if there's anything in section 5.5 that needed your attention. Okay, so this what does this want you to? You can't see anything, can you? I'm just scrolling through to see if there's anything in the homework that needs any attention that I need to explain a little bit of. All right, literally, you put this in the calculator. Literally. All right, let's see if there's anything else in here. Literally, put this in the calculator. Notice it's giving you what K and N are. Now, in the place of where they have, let me make this bigger. Whoops, too big. All righty, can you see that in the place of the compounding, they have 2, which is how many times? That's 2 is for what? What's 2 represent? Semi-annually, okay? So, again, it tells you what 2 is. What's N in this case? I called it T. So, in the homework, if it says N, it's the same thing as years. This is years. They're just calling it N instead of T. So this is 9 years. So they invested how much money initially? $19,000. At what kind of interest rate? 11%. Compounded how often?
Semi-annual.
Semi-annually for 9 years. How much money you gonna have? That's what they want to know. Now the kids just making sure you put it in the calculator properly. So with that said, I just want to make sure you're okay with what's in the homework. Let's see what the next one looks like. Open this screen back up. Alrighty, so that was number 2. Here's 3. Notice this one. It's just actually giving you the words, and then you got to fill in the formula, right? Okay, so it says find the amount of money. Look, suppose you had $10,000 is invested 5%. Find the amount of money in the account after 8 years. Compounded how often? Annually. Okay. Okay, same thing here. This one's compounded how often? Daily. There's got something else here. What about if it was quarterly? Would there be a difference? Should be. This one's okay. This one's, oh wait, this one says what? Continuously. You're going to use your PERT formula. P times E raised to the RT. That's the PERT formula. I call it PERT. Okay, this one's find the future value, okay. Alrighty. I'm just trying to see if there's anything in here that this is my lump sum one. What lump sum must be invested at 6% compounded to grow your money to $64,000? You need $64,000. So you plug in the numbers into the formula. All right, number 10. 11. Okay, nothing difficult about these. You're literally just plugging in numbers and calculating. All right, so with that said, let me look back at 6.1 and 2, see if there's anything in 6.1 and 2. There's 6.1. All righty. It wants to know what's the degree. What's the degree of this polynomial? Look at the highest exponent you see. 6. What's the leading coefficient? 12. The leading coefficient is the number that sits in front of x to the 6th. Now, what if they had written this problem? What if I have written it this way? What if I had said 45 minus 2x to the third, or 2x to the second, plus 2x to the third minus 4x to the 5th? What's the leading coefficient? -4. What's the degree? What's the degree? 5. And the leading coefficient is always the number that sits in front of the x to the 5th power. You can't come over here and tell me the leading coefficient is 45 because it's in the front. You always got to know that they wrote this in the wrong order. So you want to put it in the right order, then tell me what the leading coefficient is. So you'll see something like that on the homework, that if it's not in the right order, put it in the right order, then tell me what the leading coefficient is. All right.
Always the one that has the highest.
Always in the front. Always, always, always. Look at this one. Identify the degree. What's the degree for this one?
X, 7.
7. So it's the 7th degree. What's the leading coefficient? 1. So always the highest exponent comes first, then the next highest, then the next highest. That's the order that it should be put in. Okay? Alrighty, so this just gives you an idea of what you should expect. These aren't hard to do. It says estimate the x-intercepts. You literally can, let's see, where is this? Use the polynomial. Where is it? All right, so this is estimate the intercepts. Where does it cross the x and y axis? Excuse me, the x-axis. -2 and is that a 4? Right there, 4 and at 6, okay? Right, and then remember it says state whether the leading coefficient is positive or negative. How do you know? Look where it opens. If it opens this way, the leading coefficient is positive. If it opens this way, the leading coefficient is negative.
And then it's just acting as cubic or quadratic.
Cubic or quartic? This is cubic. Okay, so it gives you an idea of what you should expect, guys. So Monday when we come back, what we're gonna do on Monday? Study guide. Study guide, and then we'll have tests on Wednesday, and then the last 2 days, Friday and Monday, we'll study for the final exam. Alrighty, I will see you guys on Monday.